Chess is not only a sport, but also an interesting and popular game. Therefore, the gaming industry is constantly improving software products and applications for playing chess. When creating such applications, the urgent task is to calculate the ELO chess rating, which characterizes the individual strength factor of the player. The purpose of the development is to create a software product for calculating the rating of ELO chess players, which uses effective advanced algorithms and has a web interface. Stockfish Chess Engine, JavaScript technology, Node.js, Express.js were used. Three parameters are used: the total value of the discrepancy between the quality of the player's moves and the moves calculated by the engine, the final position score, and the number of moves. The software product can be used to calibrate new players in the electronic system. After all, now new users are either given a numerical value of the rating or offered to choose the experience of playing chess from a list that can spoil the fun of the first few games. The product can also be used to determine your own rating in terms of the minimum number of games played. The neural network in this project is a multi-layered perceptron with an input layer of 3 neurons, a hidden layer also of 3 neurons, and an output layer of 1 neuron. The perceptron uses the principle of learning with a teacher, with the weights of neurons which from the beginning are assigned a random value. Neural network training follows the delta rule until the error increases. The sigmoid is used as a function of activation. To obtain a data set as a player, use the Android computer application chess.com. Levels from 800 to 2900 ELO with a step of 150 points were tested. Less 2 lines of data was recorded after playing with computers with less than 1700 ELO, because they are less stable in terms of game quality. The server part of the application uses Express to exchange data with the clients in JSON format. The server opens one of the ports for listening and downloads the files to send to the client. The Stockfish.js code is also running on the server. A separate engine object is created for each client. With each response of the engine, a line is generated which indicates the depth of the search position estimate and subsequent moves taken into account which the rating is set. At the end of the search, the engine offers a course according to the force specified in the parameters. To most accurately determine a player's rating, the engine plays the strongest way only when he loses significantly in position. Otherwise, he makes a move that is simply not a gross mistake. In both cases, in the presence of alternatives that do not significantly change the assessment of the position, the course will be chosen randomly. As a result, we got a web application that uses an artificial neural network to calculate the chess player's rating after just one game with the computer. The parameters used are the total value of discrepancy between the quality of the player's moves and the moves calculated by the engine, the final position score, and the number of moves. Thank you for the attention.